All right. Well, we're about a minute after the hour, so we'll
Okay.
go ahead and get started. Hello and welcome to this ARA webinar with staff from the Council of Producers and Distributors of Agrochemicals titled Adjuvant Advantage for the Sales Agronomist. Today's webinar, the third episode of season 2, as we're calling it, focuses on adjuvants and drone application, and this is sponsored by Exacto and Invictus. Thank you to both of these sponsors for today's webinar. My name is Hunter Carpenter. I'm the Senior Director of Public Policy with the Agricultural Retailers Association, and I'll introduce our webinar speakers in just a bit. But first, I wanted to go over a few things so you know what to expect. First, thank you for taking the time to be with us today. Webinars are a very important part of the ARA professional development pathway and provide a great opportunity for ARA member companies to help educate their employees. I will say that questions will be addressed at the end of the presentation today, but you can type them into the chat panel at any time, either using the chat or the Q&A function. And today's webinar will be recorded, and that recording will be made available to on the member-only section of the ARA website. As a reminder, you can log into the member-only ARA dashboard to access past webinar recordings. And if you don't have an ARA login, you can email info@aradc.org to set one up. You'll also be able to scan a QR code at the conclusion of today's webinar and receive 1 IPM CEU credit for your Certified Crop Advisor certification. So with that out of the way, I'm excited to introduce our two speakers, Johnny Roberts, Director of Education for Adjuvant Chemistry at CPDA, and Joe Janowski, Director of Education for Adjuvant Development at CPDA. Johnny has 45 years of experience in the development and technical support of pesticide, fertilizer, and adjuvant formulation. 44 of those years were spent with Helen Agri Enterprises, and Johnny is also the co-inventor of 15 U.S. patents related to pesticide, adjuvant, and nutritional formulations. Joe has over 40 years of experience in the development of adjuvants and spray application technology. 35 of those were spent with the legacy Winfield United companies. He also holds 41 U.S. and international patents on the composition of new agricultural adjuvants, wind tunnel design, and application technology. He's the author of numerous scientific publications on these topics. And let me also say we'd like to extend a special thanks to Dr. Steve Lee with Auburn University for assisting as a technical advisor on today's webinar. And I'm now going to turn it over to Joe for some background on why today's webinar is so important and timely, and why CPDA has chosen today's topic. Joe?
Good afternoon or morning, everyone. We're going to, I think this is an important topic. We're going to cover a couple of other things first. For those that have listened to the previous ones, we've talked about this Endangered Species Act that we are, ARA and CPDA are actively trying to help our members with into mitigating buffer zones. Next slide, please. And we're making some progress here. We're back in DC now and working with the EPA to try and limit these the size of these endangered species buffer zones. And I think it is critically important to the ag retailers and to the growers in the U.S. that we do this correctly and not just do it. And so both CPDA and ARA are actively trying to work with the EPA to mitigate these in some ways. Next slide. And again, we know how to do these things. I mean, we've worked on drift and deposition of pesticides for years and years. And I think it's important to do this correctly and not just do it. And I think our ARA and CPDA members work every day to try and limit the off-target movement of spray drift, whether it be through application or water, surface water runoff and such. And what we're trying to do is to put together data, show the EPA that drift and deposition aids can greatly reduce the size of these buffer zones. Next slide, please. So the other group we want to thank is our advisory group. that works with us on the topics that we're going to cover, and then also helps us with the content as we complete these. We run it by this group here to get their input. So we're getting other outside input on the webinars we're doing. Next slide, please. Continuing education credits. At the end of this, we will have a code up so you can scan it and get the QR code to receive your 1 CEU in integrated pest management. Next, please. So we've talked about a lot of adjuvants and over the past several webinars that we did last year. And all of these that we've got listed right here were covered in previous ARA and CPDA webinars. And these and information or the webinars on these topics are on that ARA website. So if you want to refresh yourself on enhancers, surfactants, or utilities, please take a look at the previous webinars to update yourself. Next slide. So the agenda today, we kind of threw this topic out because we see this growing rapidly, and we want to talk about what's the current state of drone applications and what adjuvants are being used. We've talked to a lot of people about this. What are the application variables that we want to help correct? What are the issues when considering adjuvants through drone applications? And then what guidelines do we follow? We see a lot of suppliers coming out saying they got drone adjuvant systems, and some are very good, but we have a limited amount of testing. That's why we talked to Dr. Stephen Lee at Auburn. He's one of the people that is actively doing work on this. And so if you've got materials you want to have looked at, that's the place to probably go. There may be others, but we know he's actively has a program on this. The next slide. So I'll turn this over to Johnny. The good thing about drone application, a lot of times we cover stuff that we may not even know how to spell. At least we know how to spell drones, but truthfully, us spray and pray guys that have been doing this a long time have not done a lot of work on drone applications. And so this was kind of an exciting area to cover, and we got a lot of good input. So I'll turn this over to Johnny for the rest of the presentation.
Okay, thank you, Joe. And it's really interesting to consider that historically in my career, it was changes in the pesticide chemistry that drove the type of adjuvants we formulated and the formulations we put together. And in the future, and today, it's going to be changes in the application technology that's going to impact the type of adjuvants that we develop and the formulations we come up with. So next slide, please. So if you look into the advantage of unmanned aerial vehicles, or drones as we like to call them collectively, we have the potential to reduce pesticide use rate just from being more efficient, lower pesticide exposure to workers. We can get remarkably better deposition of spray through the crop canopy, have the option of reducing our spray application volumes and even automating spray applications. Next slide, please. So just kind of a snapshot of where we are. I was surprised when we started the search on this that there's been commercial drone applications of pesticides in Asia for more than 10 years, and up to 30% of the ag chem applications in Korea are all made by drone. China has over 40,000 of them already in use, being currently applied in various materials through. And then in the US, the estimation is that we now have 5,000 to 7,000 drones in operation, covering 10 to 15 million acres. And so as technology improves and the regulatory guidelines get better, this will expand their adoption. So to quote William Gibson here, the future is here, it's just not evenly distributed yet. Next slide, please. So what are some of the characteristics of drone applications? that we are dealing with, well, the spray application volumes are going to be in this 2 to 3 gallon per acre range. That is driven by regulatory here in the U.S. There are applications being made in Asia that are as low as 1 liter per hectare. So as a general rule, they're very low spray application volumes. The other challenge we have is that there's no agitation in the mixing tank. So that's a new world that we have to deal with. And you'll find both hydraulic and rotary atomizer nozzles in use, though with the tendency of it to go more toward the rotary atomizer for some advantages they have in these applications. And another thing that is somewhat frustrating to the people in this technology is that they actually have more in common with ground applications than they do by those that you would find in air. But the regulatory here in the US forces us to manage them as if they were aerial applications. Next slide, please. So if you look at the spray application carriers, we have water, fertilizer, and oils. In Asia, they have done some interesting things using oils as a carrier and even fertilizer. But here in the US, our application carrier is going to be water. We don't see that really changing in the near future. So our focus is going to be addressing the issues related to water as a spray application carrier. Next slide, please. So what are the negative impacts of water through a drone application? And they're the same ones we deal with on the conventional side, but we do have some additional challenges. We have the issue of spray mix suspension because we have really no agitation in these mixing tanks. There are foam and compatibility issues that are aggravated by the lower spray volumes and lack of agitation. There are coverage issues due to droplet bounce and just a general lack of spreading of a water-based carrier. And there's a potential for spray driftable fines. And as with our low spray application volumes and conventional sprayers, evaporation becomes more of a concern as well. Next slide, please. So what are the adjuvant functions on products that we have in the marketplace today that could complement drone applications? Well, of course, we have a whole range of non-ionic and organosilicone type adjuvants that can reduce spray droplet bounce and increase coverage. We have compatibility and foam reduction agents. We have also a wide range of drift reduction and deposition agents. And the deposition part of that in particular comes into focus when the goal is getting materials deeper through plant canopies and preventing evaporation. Next slide, please. So as a general rule of the work that's been today and what you find published, it's drift reduction additives, deposition aids that have the best potential for enhancing drone applications. The whole range of them have been looked at commercially, maybe not evaluated scientifically, but both oil emulsions, polyacrylamides, and guar gum-based DRAs have all been looked at through drone applications. There are some noted benefits of improved deposition and retention by using these materials while reducing the fines, but there's additional research needed to really establish which DRA type is superior. That part we really don't know. And the likelihood, because of all the various variables, there's not going to be some one-size-fits-all scenario. Hopefully there will be, but there's a lot of variables in play that may make this a more custom approach for the type of application that we're making. So we do know that nozzle types and the application volume will have a big impact on the adjuvants that we do select. Next slide, please.
And that's why, Johnny, I would add that the switch to these rotary atomizers, and Dr. Lee felt that was a growing tendency and probably the market leader now, is we haven't done a lot of research in our history through rotary atomizers. They're around since when Johnny and I started with little hand booms and stuff, but we really never, in my experience, haven't done a lot of adjuvant work through rotary atomizers. And so that's why it's a new space that has to be looked at a lot.
Yeah, it's exciting in a lot of ways. Research is what you do when you don't know what you're doing. And so we have a lot of, we don't know really what we're doing coming into play here. We can measure things traditionally, as Dr. Lai has done in previous studies, using the traditional water-sensitive paper approach of just measuring the deposits of spray droplets through canopies. Next slide, please. And using traditional substrates to collect sprays, you can see dramatic impacts of DRAs on the amount, in this case, of material that's deposited through a canopy. You can, of course, put these to data points and really get a good handle on just what these materials are doing in terms of increasing canopy deposition. Next slide, please. One of the variables that has come out in Dr. Lai's studies is that there's an impact on the vegetative canopy on the real benefit of using these DRAs. In this particular study that was done in Columbia, Alabama, you will see a difference in the amount of material that's deposited based on this water-sensitive paper versus the same type of applicator conditions on one in Blakely, Georgia. The application in Columbia was vegetation that was much thicker, canopy much thicker, while the one on the right, it was less. So the canopy is having some kind of impact on how these materials work and to what degree they provide a benefit, which is another indicator of just how much more research we have to do on this particular topic. Next slide, please. So what are some of the adjuvant formulation considerations that would come into play when you're considering using one in a drone application? Well, one of the things that we have to deal with is the uniformity of the spray mix. As a formulator, over the years, we have been able to get a lot less picky on making tight emulsions. In fact, we've been formulating them to be somewhat looser because we could rely on the heavy agitation systems and these conventional sprayers to keep them uniform. We're not going to have that luxury in these drone applications. In fact, if you have an oil-based system, oil-based adjuvant, that spray mix should be uniform for at least 10 minutes because we don't have the luxury of high agitation to keep it in suspension. As a general rule, you hear about foam being a real problem in drone applications. The oil-based adjuvants, as a general rule, have less of an issue there than the ones that are just based on surfactant. And there is a shearing issue possibly of polymer-based DRAs through hydraulic nozzles, but this will be much less of a concern with those that use rotary atomizers. Next slide, please. So another issue that it's talked about a lot commercially is the compatibility issue. Again, we're faced with the challenge here of a low spray volume and a lack of spray agitation. And so inevitably, that's going to be less suspension that we are normally used to in a conventional spray. So our suspension concentrates and our WDGs and materials like that to depend on suspensions to work are going to be a particular concern. And if there's any kind of a fertilizer, nutrient material in these low spray volumes, we tend to get clabber and separation, as you can see on the slide on the right there. And so that really adds up to a problem that we have to manage. And fortunately, we do have spray mix compatibility agents that are commercial on the market that may resolve or even prevent these particular problems. Next slide, please. So as a review of using compatibility agents and in the context of these drone applications, we would anticipate the use rates would be the same, somewhere between 1 to 4 pints per 100 gallons of spray mix, or 0.125 to 0.5% by volume. And just as in conventional sprays, they're much more effective as a preventative. And if we use them as a preventative, you can tend to use much lower range of them. And if the spray mix includes a fertilizer, then it's always wise to have the compatibility agent in with the fertilizer mixture before you add any pesticide. And one of the things that we want to stress based on past experience is that oftentimes, we talk about these jar tests of where we don't know what a particular, spray mix has done in the past. We don't have any history with it. We encourage people to do jar tests before they make the applications. It's much more of a need in these drone applications. It's always wise to conduct some type of jar test before you make the actual mixture. And one thing to be aware of when using our compatibility agents, a lot of them have this ability to disperse spray mixtures, which is good. That's what breaks up the clabber, breaks up the viscosity, and those type of things. But they're also going to make for a low level of suspension, or they could. So again, not an issue in conventional sprayers with plenty of good agitation, but it could be one in a drone application. And so this is something that you will need to do and see in a jar test. It may be an issue of just adjusting the compatibility agent rate down lower than what you traditionally do. But again, a certain amount of testing the water before you jump in it is going to be necessary with some of these spray mixes. Next slide, please. One of the concerns that's been expressed over drone applications is that because of the lower spray volumes, you could have greater crop injury. And from what the commercial experience has been so far, they're not any worse than what traditional type applications have been. It doesn't exaggerate it. It seems to be very typical of whatever a conventional application has been. There for managing this problem, you defer to the product labels, strictly follow guidelines as they're related to volume and rate. And your past experience in a conventional spray is going to apply to the drones as well. And then also, as always, when you're managing crop injury concerns, the total aspect of that spray mix needs to be considered. What type of solvent, what type of oil, and the type of surfactants that you're using. And again, you can leverage off what your commercial history and experience has been in conventional applications when you're managing this particular problem. So no real big change there over conventionals. Next slide, please. So this is probably the biggest challenge on drone applications in the US. It's an emerging application technology. The regulatory environment that is set up for it is not really tuned or really in place to accommodate it. Right now, the default from the federal EPA is that you have to have the particular pesticide approved for aerial applications. Those are the only ones that you can apply by drone. If the label does not allow for aerial application, it may not be applied by drone. And your label requirements for spray volume, droplet size, and drift must still be followed for that drone application. And one of the opportunities here that we're going to have is that the federal EPA has left this somewhat open with the states adding their own rules on this. So it'll always be a necessity that after you follow this rule of only using materials approved for aerial application, to verify that that particular state does not have any additional restrictions on that application. So when we get to the rate, and this is something that we have dealt with on the conventional side for many, many years, our growers and applicators tend to assess their input needs based on a certain amount per acre. But when we get into drone applications, we are dependent on the spray application volume to determine our rates of that adjuvant. Next slide, please. So we will be recommending adjuvants on a per volume use rate when it comes to drone applications. And so typically the amount of adjuvant used per acre is simply divided by the spray volume that is applied. And this prevents situations where, like, if you had, if you're used to making a 3 or 4 ounce per acre application, and it's going out on into a per volume basis, it can get much higher than what was intended for that particular adjuvant. Next slide, please. So determine the adjuvant delivered in ounces per acre for a specific spray volume. You simply take 128 ounces per gallon and that amount per acre times the percent by volume, and you'll get the actual adjuvant in ounces per acre, because again, that's how people assess their adjuvant needs, their uses. And in our world, what we'll be seeing in this new world of spray volume applications, we're going to be recommending like 0.25% by volume, or 0.1% by volume, 0.5% by volume, etc. That's what we need to focus on rather than the amounts per acre. To get the amounts per acre, simply follow the arithmetic that's in examples that we've given here. Next slide, please. So what are some of the customer objections, when it comes to using adjuvants in drone applications? Well, just as we get with conventional applications, some of the pushback is that if the pesticide manufacturer really needed that adjuvant as part of that formulation, they would simply build them in. And the challenge we have is that there are just too many variables to do that. That indeed would be the most desirable of this approach, if you would just build a full pesticide formulation that would address all these many variables. But there are just too many variations and spray volumes and equipment to be able to do that. The other pushback is, well, I've been doing this particular approach for a long time. I've never had any performance issues. Why should I worry about it now? And be aware that ag input formulations change, environmental conditions change. All this comes into play of having an impact of what works best in these applications. And then this is a legitimate concern. How do I know if they even need them, especially in these drone applications, with all the lack of information that we have fully? But the bottom line there is that keeping these pesticides where they're intended to be should always be a goal. So it's very difficult to argue with the point that anything that keeps these materials on target is the direction that we need to be going. Not only the issues related to environmental and work exposure, but just the issues of getting bang for that buck, to getting full activity from that given pesticide application, to minimize resistance problems and keeping that application economic. And then, of course, they're going to cost too much. And our argument there has been that maximizing efficacy is likely to be a lot cheaper than the cost of resprays and redoing and addressing issues related to application problems. Next slide, please. So, what does all this mean? I mean, the purpose of this is to explain and promote how adjuvants should be used in a drone application. So when should I use them? And the issue here becomes one, okay, what is the problem? Are you having foam issues? Is it a coverage issue? Is it one that's related to drift and evaporation compatibility? There's a lot of commercial materials on the market today that are designed to address each one of those. And again, keeping in mind our lesson about keeping it on per volume use rate, there's any range of commercial products that you should be able to fix the problem that you're having to deal with. But what are some of the other guidelines that I should follow? Well, recognizing that this is an emerging technology, and we don't have all the exact adjuvant impacts fully understood or known. So we will always refer to the adjuvant and drone manufacturer for some guidance in that. It's not like we totally don't know, but we have enough commercial experience going through and enough data to at least start. and that will improve as time goes on. And then the mixing problem issue, and again, the foam issue is the one that we've heard the most issue with, and it seems to be present always. So with that one, we would recommend that if it's a drone application and water is a carrier, just as a standard SOP, we include a foam control adjuvant. And just like we stress in conventional sprays, these products work better and you'll use less of them if they're incorporated into that water before you ever make any kind of a spray mix. And so we follow those guidelines. This problem should be one that we can really address with existing foam control adjuvants in the marketplace.
And
And
that's
then
what I would
another,
encourage, Johnny, looking at this as you go into the next season, looking at just trial and error, try and treat, I assume your water's in a 250 tote or something, just treat the entire thing and compare that to a tote with just spraying water. I think you'll see pre-adding it's probably the best. When you're using 2 or 3 gallons of water per acre, the cost is almost nothing. So I think that's probably save you a lot of time and headaches, is to consider trying that in your constant SOPs as you go forward.
yeah, it is that is the safest recommendation we can make as an always. And long history of using these materials and getting them in first, that is the best way to use them. And the same thing can be applied to any mixture that contains a liquid fertilizer. Uh, a lot of these pesticide formulations were never designed or not anticipated to go out with liquid fertilizer, and you can produce clabbering and all sorts of fallout that can really cause application issues that nobody wants to spend an afternoon with. And so if we have a liquid fertilizer in that mix, a compatibility agent is always recommended. And again, it's the same rule as the foam control agent. They should be in there first, not used as a corrective. And again, we stress the use of jar testing on any kind of mixture that has never been tried before. So next slide, please. And I believe that will open us up for some time for any questions that or comments that anyone out there would have.
Thank you for that great presentation. Let's start with the questions posed in the chat, and I'm going to pull up the QR code here in just a second so that attendees can scan that code. The first question, though, in the chat is that, do you have an estimate of drone commercial applications in Brazil? I'm certainly not going to make any guesses as to when certain things get done in other countries, but if y'all have heard anything or have any input there, feel free to.
If we got our best bet is if we got somebody listening that covers that market, may have an idea, they could throw it on their chat space there if they got a guess one. I imagine huge fields probably don't condone drones quite as much. I'm sure we don't have quite as many drones in North Dakota as we do in some of the states with more varied crops, but I don't know.
Yeah, same here. I've not heard of any specific number. I do know that they tend to have more options in their conventional aerial sprays with oil-based carriers. And so if that's the case, that could, based on what they're doing in Asia, moving to some of these oil-based systems, that may help them go further on this path than what we are here.
Dr. Lee is in the chat and has said that drone usage in Brazil is way bigger than it is in the US. So apparently this is already going on and is being used.
Yeah, I would wager that I'm just guessing it's probably in fungicide applications would be the
standard.
Because that's such a problem of getting canopy penetration for that application.
Next question wants to know if you can elaborate on atomizers leading to less shear.
Joe, do you want to take that one?
Well, I just assume, I mean, we get shear at the nozzle space, and from what I know of the atomizers, and not a long time ago than I had any experience with them, the way they work, I would think they'd have minimized the shear. And then I don't believe we have the pump circulation that we do in a commercial spray tank that's got 1,000 gallons in it and it goes through the pump many times. It would be my guess anyway.
And Dr. Lee, not to put you on the spot, but I have allowed you to talk if you want to chime in on any of these issues or add your 2 cents on some of the topics. I do think that the input that you've given to today's presentation has at least allowed you the ability to talk on some of these subjects as you're an expert. So just throwing that out there. Next question is, do you have a list of states requiring specific drone language on the pesticide label?
No, I have not seen that. I'm aware that they have that option, and we expect them to get more involved in it, but I don't have a list of what those specific recommendations are.
I will also add, at the association here, we've had a number of different ag retailers reach out to us for help in acquiring licensing and registration to pilot drones for pesticide use. There are certainly a number of different things you have to go through on the licensing side with the FAA to be able to pilot those drones. It is, or can be, I should say, an arduous process to achieve and obtain all of those licenses. And I know that they have quite a backlog at the FAA in approving some of those. So it might not be the easiest thing in the world to go through that process, but just sort of throw it out there. Next question, with a multifold reduction in spray coverage, is it fair to say that for contact products like a fungicide, the droplet should spread aggressively, say 10 times or more, to compensate for coverage issues?
I would
I think
certainly,
it would be, go ahead, Johnny.
yeah, we would. I know on the conventional settings, we've long used adjuvants to increase the coverage of these low volume sprays. So they certainly do that very well on the conventional side. We'd expect them to do that here as well.
I think for contact chemistries, absolutely. If they have systemic ability, then you're probably going to want to spread them, but you've got to keep them from drying up rapidly also. So that's the twofold problem. If contact, yeah, spread it out and let it dry there. But if it's systemic, you're going to have to keep it in a liquid state longer at the same time. So that's one of the big challenges with these low volumes, keep them in a liquid state.
Next question, is there a problem finding qualified drone operators? How widespread within today's ag retailer industry today are they using these types of newer technologies?
I'm not aware of Dr. Lee. I'm not sure if you have
Well,
any.
I would say just in my dealing with some of our members, it is hard to find people that have licenses for these operations. I'm not sure how widespread the use is, but maybe Dr. Lee can chime in.
All right. Can you hear me?
Yes.
Yes.
Okay, great. It's getting more and more common around different states. I believe if you live in the agriculture state, I'm not sure about Alaska or Hawaii, but at least in the Midwest, California, Pacific Northwest, and even down here in the Southeast, you shouldn't have problem finding fully insured and licensed drone operator to spray fields for you. I'm not saying it's very prevalent yet, but it's definitely getting more and more momentum because a lot of them talk to me for advice, and they're probably new drone spraying business, custom application being established almost like every week in the country. A lot of people are jumping on it. It's a good and bad thing at the same time. And also there was a question about the state regulation. To my knowledge, the state of Mississippi has not fully opened up drone spraying yet. And I want to say there is one state in the Northeast do not allow drone application as well. I forgot which state, unfortunately. Majority of the state Department of Ag do not have problem with drone spraying, but some of them do have concerns. So in a better way to describe it, some of these Department of Ag will hand out your pesticide permit to let you spray, but it's they're a little bit reluctant to do it just because they don't know much about it. That's where we're at right now.
Thank you. Next question is, what's the most common tank size in gallons on commercial drones? I think it's somewhere between like 8 to 10. Can you all answer that?
That is correct. For T40 is T40 means 40 liter, that's 10.5 gallons. But the answer for this question changes every year. That's how fast spray drone manufacturers release the new model. For DJI, for instance, T40 is what we use. T50 will hit the market sometime in this summer, which means 50-liter tank. T60, which has a 60-liter tanks, this is about 60, let me see, this is about 15 to 16 gallon size tank, will be commercially available in the US next year, hopefully. You know, it has been released in China. So in a nutshell, we're just seeing tank size and the capacity go bigger and bigger every year. And there is no sign that this trend is going to stop anytime soon.
And Steve, those use the rotary atomizers, correct? They're using.
Yes, sir, pretty much. Majority of the manufacturers are on board with rotary atomizer. I mean, I think the nozzle drones, the hydraulic nozzle drones still have a fit, but the market is definitely favoring the rotary atomizer, you know, by a fairly wide margin. And there are several reasons for it.
Any other questions, comments? Well, I'll leave the chat open for just a few seconds while we go over some housekeeping. I do want everybody to know about the next webinar. It will be on February 1st at 1 o'clock. I want to say a huge thanks to Copcoat Farm and Forest Protection for sponsoring that webinar, which will focus on adjuvants and tank cleanout. So certainly a timely topic as we get ready for the growing season. And then also want to note, instead of doing one in February, you get a twofer. We'll have another webinar on February 17th in coordination with CPDA. Again, all of these offer the same 1 IPM CEU credit and will be made available following the webinar with recording on both websites, ARA and CPDA, as well as ARA's YouTube channel. Feel free to reach out if you have trouble logging on to ARA, if you're an ARA member. If you're not, we'd love to have you as a member. We're always looking for new partners. And I want to thank everyone for joining today's call. I want to thank Johnny, Joe, Steve for such insightful topics and information and education. We look forward to continuing our partnership with CPDA and working to increase knowledge and awareness and education on these topics. So with that, I'm going to leave this CEU QR code up for just a few minutes. And I want to thank everyone for joining and thank you for your participation and hope you have a great day. I know a lot of people are logging off. I do have one more question. Has there been any interest in a Helio AG 272 18-gallon tank capacity? I'm sure I mispronounced that.
Well,
All right. Not sure. So with that, I want to thank you all for joining and we'll talk to you soon. Bye.
thank you.
Thank you, everybody. Have a great
Thanks,
day.
everyone. Bye-bye.